Okay, so let's keep going. So here we're still working in trigonometry. Again, we have our, see, it's not in these notes, but that's okay. It was in the last set of notes. We have, for instance, as you know, sine, cosine, and tangent. The three major trig functions, so to say, which you can remember using SOHCAHTOA. And not only that, okay, remember also we had these other three trig functions. It was secant, cosecant, and cotangent. I did give their definition and reciprocal identities, as they're called, for remembering them. So that was given last time. And also what you probably saw, I hope you saw, remember this, that I hope I mentioned it, but I think I did. All the trig functions you can actually obtain once you know sine and cosine. You can express every trig function in terms of sine and cosine. That's what I'm saying. All right. Well, anyway, let's do some more examples. So this kind of example we did last time, where you don't know exactly what theta is, except that it's acute, meaning it's between it's greater than 0 degrees, less than 90 degrees. We do know that cosine of theta is a third. Now we don't know, we can't find theta though. We don't have enough information to do that. We can still get the other trig functions though. Okay, how do we do that though from here? Well, let's make a right triangle having this angle theta, and so that this is true. Let's find our right triangle so that this is true. And obviously it doesn't have to be the scale. If you draw a triangle for an exam or something, I'm not going to measure it with a ruler and say, okay, is this exactly 1? Is this exactly 3? I'm not going to do that. If we have this kind of triangle, if you draw something like this, that's fine. And how do we know cosine of theta here is a third? Well, remember, the adjacent side, that's the side next to theta, adjacent. The opposite side is here. That's the side opposite theta, the angle. The hypotenuse is always opposite the 90-degree angle. This notation, remember, is for the 90-degree angle. It's supposed to be a square. I don't know if it's really exactly a square the way I drew it here, but hopefully you get the idea though. Now, is cosine of theta here a third? Well, cosine of theta is adjacent divided by hypotenuse. That's what we have. 1, adjacent's 1, divided by 3. So we have that. Now, to get the other trig functions, we need the side here, right? We need the opposite side. How do we get that? Well, it's a right triangle, so we can use Pythagorean's theorem. And that's what I'm doing here. Right? Remember, by Pythagorean's theorem, the length of a leg squared plus the length of the other leg squared is the length of the hypotenuse squared. In other words, it's x squared. If I call the unknown side x squared plus 1 squared, that's equal to 3 squared. So x squared plus 1 squared is 1, is equal to 3 squared, which is 9. As you can see. So now we just solve for x. So I subtract 1 from each side, right? I want x squared all alone, and I get x squared is 8. From here, we take square roots. You don't have to simplify unless I tell you to. So if you left this as the square root of 8, that's fine. I mean, I went a little bit further. Just to remind you, I guess, how you do simplify radicals, right? You want any factor that's a perfect square besides 1 added there. I went through how to simplify square roots before, but if you leave it as the square root of 8, that's fine. Okay. So, there we go. All right. that's what happens here. Now, so we have our unknown side. This side over here has length 2 times the square root of 2, or the square root of 8, you can think of it that way. I wrote it as 2 square root of 2. But once we have, once we have all 3 sides, then we're basically set. As over here, for instance, we know sine of theta, right? That's opposite divided by hypotenuse. So that's 2 times the square root of 2 over 3. We already know what cosine is. Tangent of theta, remember, that's that's opposite over adjacent. Right? SOHCAHTOA, that's how I remember these. We have opposite divided by adjacent. 2 times the square root of 2 over 1, which is just the 2 times the square root of 2, of course. Probably should have written this as just 2 times the square root of 2. Let me just do that quickly. I feel better now. I don't think it's really wrong to leave it as over 1, but it's better to write it the way I just did. All right. Now for the other trig functions below, right? I'm not quite using the definition directly. What I am using though is those reciprocal identities. Like cosecant is 1 over sine. And I said this last time, when you do 1 over something, you're basically turning it upside down or inverting it, so to say. It's reciprocal. So a fraction you would turn upside down like this. So 2 times the square root of 2 over 3. That becomes 3 times 2 over 2 times square root of 2. That's 1 over sine. Cosecant of theta, right? That's 1 over cosine of theta. 1 over cosine. Okay. So in this case, cosine we know is 1 over 3. Cosecant then is 1 over cosine, which is just 3 over 1, which is 3. And cotangent of theta is 1 over tangent. And here we had 2 times square root of 2. But if you turn that upside down, you get this. So again, I'm just unfolding the definitions here. That's all I'm doing. I mean, you could actually get tangent by using sine